Hello everyone, welcome to my YouTube channel Easy Scholastic. I am Jasmine. In today's session, we are going to solve a problem under electrical analogy in mechanical rotational system. Okay, so let's start solving the problem. The question is, write the differential equations governing the mechanical rotational system shown in figure. Draw torque, voltage and torque current electrical analogous circuits and verify by writing mesh and nodal equations. So our first aim is to write the differential equation. Our second aim is to find what is the mesh equation, and the third step is to find what is the nodal equation. Okay, so on analyzing the diagram, we have nodes J1, J2 and J3. So we have three nodes, and also the torque is given to node 1, but there is no displacements. So we are going to assume the displacements as theta 1, theta 2 and theta 3. Okay, now let's start solving the problem. So to the node J1, what are all the elements connected? K1 and B1, also torque T. To the node J2, what are all the elements connected? B1, B2 and K1. And also to the node J3, what are all the elements connected? B2 and K3. Okay. So our first step is to identify the number of nodes. Here we are having three nodes, J1, J2 and J3. So we can say that number of nodes is equal to 3. Our second step is free body diagram. Since we are having three nodes, we will be having three free body diagrams. So to the node J1, we have a applied torque T and angular displacement theta 1. To the node J2, we have angular displacement theta 2. And to the node J3, we have angular displacement theta 3. So what are all the elements connected to J1? B1, K1 and T. So the opposing forces are TJ1, TB1 and TK1. Node 2, we have B1, B2, K1. So the opposing forces are TJ2, TB1 and TB2. One more element is TK, TK1. And what about node 3? We have B2 and K3. So here it is TJ3, TB2 and TK3. So our step 3 is to write the differential equation for three nodes. So for node 1, the differential equations are Tj1 is equal to J1 into d square theta 1 by dt square, and Tb1 is equal to B1 into, B1 is connected between 1 and 2, therefore it is d by dt of theta 1 minus theta 2, and similarly Tk1 is equal to, K1 is also connected between 1 and 2, therefore K1 into theta 1 minus theta 2. Similarly for node 2, the expression is Tj2 is equal to J2 into d square theta 2 divided by dt square, and Tb1 is equal to B1 into d by dt of theta 2 minus theta 1, and Tb2 is equal to, B2 is connected between 2 and 3, so that is B2 into d by dt of theta 2 minus theta 3, and next is Tk1, Tk1 is equal to K1 into theta 2 minus theta 1. For node 3, Tj3 is equal to J3 into d square theta 3 divided by dt square, Tb2 is equal to B2 into d by dt of theta 3 minus theta 2, and Tk3 is equal to, K3 is connected to 3 alone, therefore K3 into theta 3. Similarly, I have applied Newton's second law for node 2 and node 3, and I have substituted the expressions with the help of the differential equation. Okay, so for node 2, on applying Newton's second law, I have got an expression, I have taken it as equation number 2. Similarly for node 3, I got an expression which I have taken it as equation number 3. I am going to apply the condition, that is I am going to replace theta as integral of omega dt and d theta by dt as omega, and d square theta by dt square is d omega by dt. So omega is nothing but angular velocity. Now I am going to rewrite the equations 1, 2 and 3. So my first equation becomes t is equal to j1 into, so d square theta 1 by dt square is d omega 1 by dt plus b1 into d by dt of theta 1 minus theta 2 is omega 1 minus omega 2 plus k1 into integral of omega 1 minus omega 2 into dt. I am going to take this as equation number 4. Similarly, my second equation becomes 0 is equal to j2 into d omega 2 by dt plus b1 into omega 2 minus omega 1 plus b2 into omega 2 minus omega 3 plus k1 into integral of omega 2 minus omega 1 into dt. I am taking this as equation number 5. Similarly, my third equation becomes 0 is equal to j3 into d omega 3 by dt plus b2 into omega 3 minus omega 2 plus k3 into integral of omega 3 dt. I am going to take this as equation number 6. All these three equations are called as differential equation, which is our first target. So our first target is obtained. Step 4 is to find torque voltage electrical network. So the assumptions is B, J, K is replaced as, B is replaced as R, J is replaced as L and K is replaced as 1 by C. Okay. And torque is replaced as voltage. Okay. And this theta 1, theta 2 and theta 3 are replaced as currents I1, I2 and I3. And what is the law we are going to apply? Kirchhoff's voltage law. Okay. So this is our given diagram. This is our hero here. Node is our hero. Node is J is the node. So how many nodes are there? 3 nodes are there. So J1, J2 and J3 I am going to replace. J1 is replaced as L1. J2 is replaced as L2 and J3 is replaced as L3. Okay. Since there is no common element between 1 and 3, okay, we can draw the nodes separately. That is node 1, node 2 and node 3. L1, L2 and L3. Now let's check whether there is any common element between L1 and L2. So to node J1 and J2 we have common element K1 and B1. So K1 is replaced as 1 by C1 and so this is B1. B1 is replaced as R1. So I am going to draw these two in series between 1 and 2. So that is C1 and R1. C1, R1. Okay. Similarly, between 2 and 3, is there any common element? So between 2 and 3, I have a common element B2. So B2 is replaced as R2. So between 2 and 3, I have an element R2. Okay. Now check to the node L1, we have a torque, applied torque. So torque is replaced as voltage. So I am going to replace the torque as voltage. Okay. Now to the node L3, do we have any specific element? That is K3. So K3 is replaced as 1 by C3. So I am going to replace here as C3. Now I have done with all my connections. I am going to assume the loop 1, 2 and 3, and to the loop 1, I1 is the current, I2 is the current flowing through loop 2 and I3 is the current flowing through loop 3. Now apply Kirchhoff's voltage law to loops 1, 2 and 3. So as we know, for resistor voltage is equal to IR, for inductor voltage is equal to L into di by dt, and for capacitor voltage is equal to 1 by C into integral I dt. I am going to write the formulas. So for loop 1, I have an applied voltage V. V is equal to L1 di1 by dt plus C1. So it is 1 by C1 into integral of I1 minus I2 into dt plus R1 into I1 minus I2. I am taking this as equation number 7. And to loop 2, my formula is 0 is equal to L2 into di2 by dt plus 1 by C1 into integral of I2 minus I1 into dt plus R1 into I2 minus I1 plus R2 into I2 minus I3. I am going to take this as equation number 8. My third loop is 0 equal to L3 into di3 by dt plus R2 into I3 minus I2 plus 1 by C3 into integral of I3 dt. I am going to take this as equation number 9. So all these three equations are called as mesh equations. The step is torque current. So the assumptions for torque current is B, J, K is replaced as 1 by R, C and 1 by L. Now here the torque is replaced as current. Okay. And the angular displacements theta 1, theta 2 and theta 3 are replaced as voltages V1, V2 and V3. Similarly, here we will be applying Kirchhoff's current law. So who is our main hero? J is our main hero. How many J are available? 3 J's are available. So I am going to replace J1 as C1, J2 as C2 and J3 as C3. So let's recall the formula. For resistor, the current formula is V by R. For inductor, the current formula is 1 by L into integral V dt. And for capacitor, the current formula is C into dV by dt. Now instead of J1, J2, J3, I am going to replace C1, C2, C3. So this is my first node, this is my second node and this is my third node. So here I am replacing this as C1, this as C2 and this as C3. We check what are the elements connected to C1. So to the C1 we have torque alone. So torque is replaced as current. Therefore to C1 I am connecting a current source and naming it as I of t. Okay. Now let me check, is there any element between 1 and 2. So to 1 and 2 I have two elements K1 and B1. K1 is replaced as 1 by L1 and B1 is replaced as 1 by R1. They are connected in series. So I am going to connect here in parallel. So this is L1 and this is R1. In between 2 and 3, I have a common element B2. So B2 is replaced as 1 by R2. So I am going to connect as R2. So to the node J3, I have only one element K3. So K3 is replaced as 1 by L3. So I am going to connect here L3. Now to the node 1 I have a voltage V1, to the node 2 I have voltage V2 and to the node 3 I have voltage V3. I am going to apply Kirchhoff's current law to the nodes 1, 2 and 3. So to the node 1 if I apply KCL, what is my answer? I of t is equal to C1 into dV1 by dt plus 1 by L1 into integral of V1 minus Vt into dt plus V1 minus V2 divided by R1. So this is my 10th equation. Now if I apply KCL to second node, what is my answer? 0 is equal to C2 into dV2 by dt plus 1 by L1 into integral of V2 minus V1 into dt plus V2 minus V1 by R1 plus I have an element R2 common to 2 and 3. So V2 minus V3 divided by R2. Going to take this as equation number 11 and third node implies 0 is equal to C2 into dV3 by dt plus I am having the element R2 common to 2 and 3. So V3 minus V2 divided by R2 plus L3 is connected to node 3 alone. Therefore 1 by L3 into integral of V3 dt. So this is my equation number 12. So all these three equations are called as nodal equations. Okay. So if I apply the assumption values in the differential equation for torque, voltage and torque current, I will get these sets of equations. So from this, the equations like mesh equation and nodal equations are verified with the help of the differential equations. Okay. So with this, the problem is over. Thank you for the patience. If you have any queries, please mail me. Don't forget to like, share and subscribe. So with this, the electrical analogy topic is over. Okay. Thank you.